Welcome back to finish up section 5.1. So there's one more big idea in 5.1 we need to cover, and that is the idea of end behavior. Okay, so end behavior basically talks about what does the polynomial function do when it's moving off to the left? What is it doing when it's moving off to the far right? And there are two things you have to determine for this. All right. So the two things that you want to look at are look at the degree of the polynomial. Okay. Is it degree 1? So is it linear? Is it quadratic? Is it cubic? Is it quartic? Is it quintic? So look at that degree. Okay. Because even degrees, so 2, which is quadratics, 4, which is quartics, so on and so forth, they all will act like parabolas, okay? They all kind of look parabolic shaped, okay? And odd functions will all act like lines, okay? And here I'm talking about end behavior. All right? So, what do I mean by that? Well, I mean, look at this. So here, the parabola is going up and up. Here's a degree 4, and I'm going to kind of takes on that same thing, and towards its end is going down, down. Okay, so even the degree 4 at its ends is going to act like a parabola. Here, odd degrees will act like lines. So both of these are or this is a degree 3 and a degree 5 polynomial. So look, if I were to kind of just transpose a line onto this, that's how it's acting. Transpose a line onto this, and that's how it's acting. Okay, so again, evens will act like quadratics, odds will act like lines. Well, there's still another piece that we need to know, and that piece is looking at that leading coefficient. If that leading coefficient is positive or negative. So what I mean by that is look at this. So this is a positive right there. That is a positive 1. Okay, and remember positive means the parabola opens upward. So that's why this we would call an up, up. This negative right here, that negative means that the parabola, even though, remember, not quite a parabola, but its ends will act like one, are facing downward, giving this one the end behavior of down, down. All right, so for evens, think a parabola, okay? And when the leading coefficient is positive, is opening to the up, or is opening up, so the end behavior is up, up. If that is negative, then that would indicate that it's opening downward, so it would have an end behavior of down, down. For odd, remember, think a line. Okay, so here this is a positive 2, so here, I'm just going to sketch it one more time as I'm emphasizing this. Positive, think of a line with a positive slope, okay? Doesn't that look like a line with a positive slope if you're just stretching it towards those endpoints? So positive slope, what's it going to do? Well, it's starting at its bottom and then working its way up. So this one would be down, up, and then when it's negative, think of a line that has a negative slope like this. It's starting up and it's moving down. So as long as you can remember the basics of what to picture, then you should be absolutely fine. So a positive means think positive slope, so it starts down and it's working its way up. Negative slope starts at its top and is working its way down. Okay, and again, all I'm looking for are those words, up, up, down, 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 up, or up, down. Okay, so let's try a couple. Okay, just so you can kind of get an idea, because I know that's a lot to kind of throw at you all in once. So remember the two things that we're looking for, okay? The two things we're looking for are, it is an even degree, okay? So even degree, and that first term is positive. So even degree positive means I should be picturing a parabola that's opening up. Okay, I'm picturing a parabola that's opening up like this. Well, that means I'm going to have up, up behavior. And so that's really all you need. The answer of the end behavior is just up, up. Everything else I'm tossing up on the board is just kind of an exercise to get you thinking about what it's going to look like. Okay, and of course that picture shows you that you're right. It shows you up, up behavior. But of course, on the test, I'm not going to give you the visual. You're going to have to be able to look graphically and figure it out. All right, for this one, we have even. So even means picture a parabola, and negative. So a parabola that is opening down. So a parabola that's opening down, I'm seeing down, down behavior. And again, that's the actual answer. Everything else I sketched up on the board is just that. It's kind of scratch work to sketch work to make sure that you can get to that proper answer. And of course, the picture that comes with it does verify that that's what we've got. This next one, this next one is odd. So odd means we need to think about a line. And that negative means we need to think of a line that has a negative slope. So a line that's going like that. So a line that is starting up and ending down. Okay, so this one would have behavior up, down. And again, the picture here verifies that. Okay, but your actual answer, all you really have to give me is up, down. All right, so now let's try some with just the equation given, okay? So you can't really cheat and look at the picture, because again, that would kind of defeat the purpose if you're just looking at the picture. So here, the two things I always look for, degree is odd and it is positive. So odd positive means I'm picturing a line with a positive slope. And what is a line with a positive slope doing? It's starting down and working its way up. Here I see an even negative. So even negative means I should be thinking of an upside down parabola. And what is an upside down parabola doing? Well, both ends are going down. Next one. So I see an odd negative. Excuse me. Odd negative means a line that has negative slope. So it's starting at the top and it's working its way down. And here, an even positive is like a parabola opening upward. To the left, it's going to be going up, and to the right is going to be going up. Okay, so and if you just know to check those two things for me, then you're going to ultimately be just fine. All right, so let's put this all together. Let's combine this idea with the things we were talking about yesterday, shall we? So standard form. Standard form, so here I have a fourth power, all right? So I have negative 2x to the 4, because that's the largest power that I have. Next thing that I see, 3x plus 2x, is I see 5x, and then finally at the end, minus 1. So standard form, again, means combining like terms and means writing them in order of highest degree first. All right, now that I have that, now let's name it based on the degree. Well, its degree is 4, so if I look back at my table, that is going to be a quartic function. 1, 2, 3. I have 3 terms, so that is a trinomial. Okay, this has an even degree, and the first term is negative. So I should be picturing an upside down parabola. So that means its end behavior is down, down. All right, now a little flash forward for tomorrow. Tomorrow we're going to be talking about relative max and mins, okay? And the lead into this is the idea of turning points. So turning point is the same thing as a max or min, okay? So basically what it's talking about are these points right here. So here, in terms of a quadratic, we're talking about that vertex, okay? For cubics, we're talking about these points right here, wherever it is potentially turning around, okay? That is called a relative max or min, okay? And a polynomial can only have as many turning points, oops, sorry, I misspelled that, as many turning points as one less than its degree. Okay, so for example, degree 1, which is a straight line, is going to have 0 turning points. Okay, degree 2, well, it can have at maximum 1. Okay, and it does. It has its vertex. Degree 3. Now here's where it starts getting a little bit different because it can have no turning points. Okay, so here it doesn't have any. Or it can have 2. We can turn around twice. Once here and here. But notice there is no way for it to only turn around once. Okay, so not everything is a possibility. Here only 0 and 2. So let's think about quartics. Okay, how many could quartics have? Well, quartics, if it can only have up to 1 less than its degree, it could have only up to 3. Okay, and let's look at the different ways a quartic could look. So here, I can have one where it has 1 turnaround point. So basically, like a quadratic. Or here, if it goes up like this, it could have 3. Okay, because the important thing is it can only have as many as would allow it to angle back up. So here, it has that proper end behavior, right? That's the key. Why here, quartics need odd amounts because it has to be able to turn around to back facing the same way it was before. Where odd degrees need even amounts because it wants to stay opposite of what its end behavior was before. All right. So just a little prelude to tomorrow. So thank you so much for joining me for this. And please make sure you take a moment, write that summary, and then come back ready to do your practice work.